All right, guys. Hope everybody's hanging in there. I don't know about you, but I'm getting pretty bored. I'm usually okay staying home and being a homebody, but not having the option to go to the mall or the movies or the zoo or do something is starting to get old. So I'm really hoping that this is going to blow over soon and we can all kind of get back into our normal routine. All right, so we're in our second week of e-learning for the fourth 9 weeks. Today we're going to be talking about tangent lines and circles, and we'll review a little bit of things that we talked about in our last couple of lessons. So this is section 12.1. And I don't know if it's going to take us more than just today. I think there's a little bit left I need to cover. So if it's not too difficult, then I might try to do that on the next lesson. All right, so a tangent. A tangent is a line that's on the outside of the circle, and it only touches the circle in one spot. So if you look at our diagram, AB is on the outside of the circle, and it's only touching the circle in exactly one spot. So that's what makes it a tangent. And the spot that it touches the circle is called point of tangency. So on this particular diagram, B would be the point of tangency. So I have that listed over here. AB is the tangent and B is the point of tangency. Let's remember from a line or a segment, that goes from the center to the circle. That's called a radius. So the RB is a radius. Now, if we had a line that went all the way across through the center, if you remember, that was called a diameter. So let's say if we had another dot over here and it went all the way across, we would call that the diameter. So RB is the radius, and anytime you have a tangent line, it is always going to be perpendicular at that point. So if you notice my right angle I wrote right there. So AB, my line AB, is perpendicular to any radius, but in this case, the one I have marked, which is RB. So that's a main point to remember, that a tangent line, when it touches the circle in that one spot, it's actually forming a right angle at that intersection point. That's going to help find some missing angle measurements like on this next problem. All right, so I'm just going to do one example today, and then you have some homework problems on the quizzes. So one of the problems on the quizzes is almost identical to this example right here, okay? And I even wrote it on the quizzes. It's like the second example, or the second diagram, So it says ML, which is right here, and MN are both tangents. They're telling you that they're tangents. They're only touching the circle on one spot, even though I didn't draw it that well. So I know that those are tangents. And because those are tangents, even though they're not marked, I know that there's right angles right here. That's going to help us in a second. And it wants me to find the value of X, which is right here, and then they tell me that this angle is 117. All right, guys. Well, first of all, as long as you know everything but one, like if you know all of the missing angles but one, you can find that missing angle. If you know all the angles but the missing one. So I know 3 of them. I'm going to show you in a minute how I know 3 of the 4. All right, so I have a 4-sided figure. It's just a quadrilateral, okay? We learned back in the third 9 weeks, any 4-sided figure is equal to 360 degrees on the inside, like a square and a rectangle. We know that those are 360. So any 4-sided figure is 360 degrees. So I know that I can take angle O plus angle L plus angle M plus angle N, and I can add all 4 of those angles and set it equal to 360. Now what I'm going to do is I'm going to replace 3 of the 4 angles with their actual measurements, okay? Now I told you a minute ago that since these are tangent lines, that angle L and angle N are going to be 90 degrees. And that's because of this definition right here. So I'm going to replace angle L and angle N with 90. That's where those 2 are coming from. And then they're telling me that angle O is equal to 117. So that's where that's coming from. So the only thing I have left to find that I don't know is angle M. So I have 3 of the 4 angle measurements That means I can find that angle M, the missing angle measurement. So I'm just going to add the 3 up together. So 117 plus 90 plus 90 gives me 297. And then I just subtract 297 from 360. So angle M, which is really X in my example, is 63 degrees. All right, so you have one problem out of the like 7 or 8 problems. I can't remember how I gave you. One of them is almost identical to this. And then the rest of them are asking different questions about which line is a tangent. So remember, a tangent only touches the outside circle in one spot. Makes a right angle when it does that. It might ask a couple of review questions, like which of these lines is a radius, or what makes a radius, or a diameter. So remember, a radius goes from the center out to the circle, and I don't have it listed, but a diameter would go all the way across, through the center and all the way across the circle. Okay. If you have trouble, you can always refer back to the other 2 videos that I posted in the first week of e-learning. Again, I hope everybody's doing well. Make sure you do the assignment quizzes. Make sure you also do the attendance quizzes. And then don't forget, you can email or text me if you have any questions. See you later.